on a lookout,
Yeah.
or to land, if that's the procedure they have developed, is definitely a use case.
So I wonder about that the normally fixed wing used by the Air Force, that is faster and more high altitude
Yes.
than the enemy drones. But
Yeah.
Army aviation, for example, the Army aviation, the Black Hawk is very important asset for the Korean Special Forces. And if they infiltrate to the enemy deep area, they fly under the low altitude. In this case, the enemy can use the FPV drone to attack the forces helicopter. So I already heard about your presentation. Those kind of gears the advantage. It cannot disrupt the Bluetooth frequency or band. And we can put in our vehicle or our helicopter. It can be a good solution for enemy drones attack, isn't it?
Absolutely. And we've done some, we haven't done fixed wing yet. It's definitely possible, but rotary wing is absolutely a good application for this because it's moving a lot slower and they're more susceptible to those altitudes that those drones fly at.
Yeah.
Yeah, certainly.
That's great. Is there any kind of interference with rotator wing? Helicopters rotator wings might interfere that its antenna function?
If the actual receiving, I don't think so with the acoustics. From the limited testing we've done, it had no effect.
Okay.
But in terms of like any sort of weird like frequency that is coming off of it, maybe there's possible.
Rapidly rotating RPM rotors might be interfering a lot of things, even including the our VHF radios.
Yes.
Sometimes as well. So yeah, I'm actually afraid about those rotating
Part of
wings.
Part of the mission planning for it's becoming more important for communications to not be on drone frequencies or known drone frequencies to confuse detectors or to stop them from being jammed unintentionally.
Thank you, sir. Thank you.
Let's move to this one. If we have more questions, then we can talk about them during the demonstration. There's definitely some downtime between runs. So this is the diver. It stands for direction indicating version ruggedized. It has the ability to give those sectors. It's a very similar form factor, just bigger. There are more radios in this and more and larger computer components to be able to determine signals and run through the entire RF spectrum faster to get faster detect. So the inputs are very similar. You have power, you have Ethernet, and then you have all of your antenna cables that are right here. So what these cables lead to is your array of antennas. You have one omnidirectional antenna, just like this one. This is an older style antenna, but it's doing the same thing. This is where we get our precision data, where we can get it from. And then we have two half radome antennas.